So we're recording. So remember valgus, it's gonna be knees that are coming in, knock-kneed. Varus, that's gonna be bow-legged. When we're talking about tibial torsion, that's gonna be literally where your tibia is twisted, so to speak. So your foot effectively is gonna be pointing out or pointing in. So naturally when you're running, you wanna pretty much put your foot straight in the ground and drive yourself forward. But if you naturally have this rotation out, you're gonna have to actively internally rotate your legs when you're running, which is gonna put some asymmetric stress on the knee joint and otherwise, or depending on if you have the other direction, you're going to have to externally rotate your legs while you're running, and both of which are not going to be that efficient. It's one of those things you'll be able to live life and be fine, but obviously doing a number of sports are going to be far more difficult, and your joints arguably are not going to last as long because of those issues. So yeah, Magnis effect, remember guys, that's that overall spinning effect where we're going to create a higher pressure gradient on one side from the seams pushing the air down, and then we're going to be lifting the air and pushing it up on the other side, so we're going to curve in that direction. Vortices is going to be that swirling force along with, you know, if we're increasing our drag factor, we had to increase our velocity. So factor of 1, then that's going to increase by a factor of 1 squared, because remember it's velocity squared in that formula. Where the axis is where we get rotation, lateral flexion, and flexion extension. Our atlas is only giving us flexion and extension. Anthrometrics is going to be the size, weight, shape of different segments of the body. So things like your height, your wingspan, your waist measurement, your hip measurement, all of those are going to be anthrometrics. Things like your age, your skin color, those are not anthrometrics. Okay, so remember when it comes to skeletal muscle, we've got those 4 major components. We've got excitability, we have elasticity. What else do we got, guys? Yes, irritability, which is a fitting one to bring up whenever, you know, for some folks, this might be a little too early in the morning. But then again, judging from how many people are in class, I imagine it's the ones that didn't show up today that's going to be the irritability for the early mornings. Yes, and extensibility. Good job, Braden. Awesome. And the ability to develop tension. Great job, Haley. Okay, so if our goal is to increase bone mineral density, what do we need to do, guys? Okay, now, you're not wrong. There's a number of nutrients that are going to be very useful for increasing bone mineral density. Calcium being a major one, vitamin D being a big one. Oh, thank you, John. Exactly, that's the other side of it. Vitamin K and magnesium, all are going to be important in bone mineral density, but the other component is we need to apply stress. Now, when we say provide stress, what are we talking about? Neighbors? Sounds like it come from over there, so might be them running their hose. So what type of stress is it? Are we gonna make our bones study for a final? Are we gonna make our bones go through a bad breakup? We're gonna make our bones go through a, yes, workout. Good, and specifically what type of exercise is gonna help us increase the bone mineral density more so than just say another? Yes, weight-bearing activities. Good. And when we talk about weight bearing, guys, then we need to think about the impact forces. So if I was going to have you guys do a bunch of, we'll have a comparison, okay? You're going to go walking on a treadmill, okay? You're going to be jumping rope, or you're going to be riding on a bicycle. Which of those 3 do you think you're going to have the biggest increase in bone mineral density? Yes, jumping rope, because you have those constant impacts, and those impacts are going to give us those greater forces. Think back to the jump lab where you saw literally how high that force was on the landing, even when someone's trying to control themselves. And those forces are being absorbed through your bones, through your tendons, through your muscles. And that's what's going to force them to remodel. Now, your bones are going to adapt to the forces that are produced by the muscles or the forces they have to effectively receive from whatever muscular work you're doing. So weight training is another good way to increase bone mineral density, but obviously low-level plyometric exercises, so this would be things like running, jogging, those are going to also increase bone mineral density. Remember 49, when we talk about decreased resistance to motion, that's going to be a higher temperature, lower air pressure, and a higher amount of humidity. So remember, we've got cortical and trabecular bone. Which of those two are going to do a better job of dealing with strain? Because remember, yeah, those cortical long bones, they're much more rigid, so they're not going to really, they're going to be able to deal with more stress, but they're not going to be able to deal with that bending of that strain. And like anything else, they're both going to remodel to the tissue or to the stress you're doing, trabecular to a much greater degree. So what do we do in order to increase our stability? So remember, if we, if we're just talking about, we want to lower our center of gravity, we can always try to gain weight, which I don't know how you're going to do it that rapidly to help with an oncoming object. We're going to widen our base of support. We're going to put our center of gravity towards the oncoming force. We're going to make sure our center of gravity is lined up well within our center of mass. All of those are going to help with increasing our stability. Okay, remember guys, this is going to be either straight or pennated muscles. So fusiform or pennate. Remember, whenever we happen to have a unpennated muscle, it's going to be much more effective at high velocity movements because it's just pulling in that straight line, so it's going to be the fastest it can be. It's going to be the ones that are pennated, so that's going to be the ones that pull in angles. That's going to be the one that's going to give us a greater amount of force production. What else you guys want to work on? And if you guys got questions about working on your projects, breaking down the physics for whatever you're doing for your movement, please let me know. I'd be more than happy to talk through it with you guys. Oh, sweet. Okay, what is the force required for a deltoid that inserts 5 centimeters down and 0.751 meter arm that weighs 5 kilograms and moment of inertia is located 6% of its length in the shoulder joint and the arm is held perpendicular to the floor, meaning right out here. Deltoid attaches at a 10-degree angle in newtons. So we're going to have our vert force times 0.05 equals our 5 kg times 9.81, so we can convert that into newtons, times 0.751, but we're only at times 0.6 because we're at 60% of that. Sorry, I'm not trying to do this in European methods. Just gravity. And then that effectively is going to be for the percent it's at. Okay. Now, once we factor all of this out, we still need to have the actual force the deltoid's producing. And it's that 10-degree angle, so it's really, really steep. So that means we're going to go ahead and have effectively what'll be sine of 10 degrees equals the vert force over the delt force. So then you just have to go ahead and do a little algebra and you'll have your answer there. So for Braden's question, center of mass of the foot is important when finding the force produced in kicking the soccer ball. Because remember, you're not just hitting the ball, but you're also having to move your foot and your lower leg and your thigh. So all of those are going to be added up together whenever we're looking for the force of the hips. If you're looking at the force produced by the ankle, then you need to have the center of the mass of the foot as well as the weight of the soccer ball. Yes, because if you're doing the ankle, you need to have obviously everything that happens to be attached to the ankle. Yeah. For the foot that's striking the ball, you just need the ankle itself, the center of mass of the foot, and then what we would figure the weight of the foot is, along with obviously the weight of the soccer ball itself. Now for the support leg, you're only looking at all of the body weight above. So we're looking at really the rest of the entire body, including the opposite leg and foot. So it's you just subtract only the foot from there, and then you're having to support all that through that single ankle. Yes, and you break it down for each phase of the motion. Any other questions you guys want to work on? right, number 20. Okay. What is the angular acceleration of an object if it starts at 13 degrees per second and increases to 18 degrees per second in 10 seconds? And it has a radius of 1 meter and a mass of 10 kilograms. This is what we call misdirection. The only things you need is the 18 degrees and the 13 degrees. So our final is 18, our original is 13, and then we're going to go ahead so 18 divided by 13, or 18 minus 13 divided by 10. So altogether, we're going to be left with what is going to be 0.5. A carousel is going to be one of those things you see at like amusement parks and otherwise that go around in circles that like little kids will like ride on what looks like a horse or otherwise. I think it's the thing that they have a giant fight on at the end of the first season of The Punisher on Netflix. Also, a song by Finger 11 that I'm a fan of. Yes, hands down, it's going to be flexion, John. You want to be in a neutral position or an extended position. You do not want to go ahead and be in a flex position when you're doing rotation, specifically when we're going against a lot of loads. I'm going to sing us the song of your people. Yeah, we're not going to have you guys do lab 6. You don't have to worry about it. Unless you really, really want to. Any other questions you guys want to go ahead and go through this morning? Or you guys need to go ahead and look at this some more, try some of them on your own, and then come back later? I know, Tinks. I'm trying to get the kids to talk. They just don't want to talk. And that's all right, John. Okay, so if you guys are okay with getting out early this morning, then let's go ahead and we'll call it a day here. On Thursday, obviously, the goal is for you guys to have some more questions of things you want to review on, or questions when you're working on your own project, to make sure that you go ahead and are getting everything done, and you're going to, knock it out of the park, get a full 50 out of 50 on it. Sorry, I'm trying not to get whacked in the face by my cat's tail. And then, okay, kitty, say hello to the class. And now let's go ahead and transition back to native ground. So take care of yourselves, guys. Stay safe out there. I will obviously see you guys again then on Thursday. With kind of do it the way we've done it today. You're going to go ahead and write, just put the number up in the chat of the one you want to go ahead and, oh, wow, she just deleted all of that, didn't she? Oh boy, the joys of pet ownership. Okay. So we'll come back and we will keep reviewing on anything you guys want to review on. And then remember, your goal is to have your presentations effectively ready to upload next week. And we'll just be able to put those up, so everybody's gonna be able to kind of watch and give each other feedback. And then I'll be able to get that grading done. The final, you're gonna be able to take that. I think effectively it's really open whenever. You can go ahead and get after it. Now, the only thing that I'm gonna say is twofold. One of which is, after anyone starts the final, we are not going to review for the final anymore. So, if you decide to start the final today, great. Because I guess technically I'm not teaching for the rest of the semester, which in this class, which kind of sucks. But because obviously someone's already taken it, so let's not try to have it so everybody else can kind of know, what the questions are at that point. Even though obviously my reviews are there to really help you guys on the exam. Otherwise, just keep doing your best, folks, and we will chat more about this when I see you guys on Thursday. So. There's no other questions, comments, concerns. Have yourself a great day, guys. And yeah, or Caitlin, I think you just hopped in. You have any questions? You want me to help your review for the exam? And Caitlin has left. I will not take that personal. Fair enough. Well, have a great day, guys. Thanks for coming this morning, and stay safe out there. Bye-bye.